Hi, everyone. This is Dr. Mahmoud, and I am here to share with you a simple, quick video on how to differentiate the simple interest rate from the compound interest rate. As you know, we did discuss that in chapter 2, and here's a summary of it. I'm going to share my screen. I will provide you with an example, and this will hopefully make it easier for you. So as we discussed, the interest rate, it's some charges that the banks and organization charge people because they're giving money and make this money available for people. So people are willing to pay the extra fees and charges to have this money available for them. For the simple interest rate basically does not consider the time value of money, and it's not common. Basically, we don't use it in real life. However, the purpose of this class is to teach you about real life application, and the compounded interest rate is the most common one. It is the one that we use in real life. And it does reflect the time value of money. And basically, the interest rate does not charge you interest on the interest. However, the compounded interest rate will be charging interest on unpaid interest and unpaid principal. So let's take this example to demonstrate the difference between both principles. The simple interest rate, we started with a $10,000. We have 3 years as a period, and we have the interest rate to be 10%. So on year one, the interest, if we're dealing with a simple interest rate, that would be F equal to P plus P times I times N. And that would be, if we're going to find out the interest by the end of year one, that would be the 10,000 times the interest I times, we need to find out the interest only for 1 year by the end of the year. So that would be N equal to 1. So we know that it's the interest would be $1,000. So the total amount would be the 10,000 plus the 1,000. And now for the second year, we're going to use the same principal amount, the $10,000. So that would be 10,000 times, again, the 10% times, we need to do it for 1 year. So that would be a 1,000. So the total would be 11,000 plus the new 1,000 interest. And for the last year, year 3, would be the 10,000 times I, 10%. Again, we're going to calculate the interest for only 1 year. That's why you see N equal to 1. And add these together would be 12,000 plus the 1,000. At the end of the year 3, we have to pay negative 13,000. And then the negative because you're paying it. It's a negative cash flow, something going out of your pocket. So this should be negative. All right, let's demonstrate this compound interest rate. The compound interest rate would be considering the time value of money and the interest on the top of unpaid interest and principal. So by the end of year 1, we will be charging the 10,000, 10%, and times 1. That's just only for 1 year. And we'll go on now to total. The total would be 10,000 plus the 1,000. So the total is 11. Now for the second year, here's the difference. The second year, we're not going to deal with the 10,000 anymore. We will be dealing with the $11,000. That's the new principal amount times 10%, and that would be 1,100 is the new interest rate for year 2. And now we add 11,000 plus the 1,100. And now for the year 3, again, we're not dealing with the 10,000 anymore. The principal amount is not 10,000. It's the 12,100. And now there's another 10% on that. That would be 1210. And now the total would be 12,100 plus the 1210. And that will give you the total amount by the end of year 3 with a compound interest rate of 10% would be equal to 13,300, and therefore we have to pay the negative 13,310 to the bank, which means given paying it, it's a negative cash flow, and you will see the difference between the simple interest rate and the compound interest rate, there's about $310 difference between both. So it is different. Again, just to summarize, the simple interest rate based on the 10,000, and we use the 10,000 on year 1, 2, and 3. However, the compounded interest rate, we don't use the 10,000. We use the cumulative work, the total, to find out what would be the total amount. Last thing that I want to say, can we do this calculation in a different way? Again, this is just this example to simplify things, to make sure that you understand the difference between the simple and the compounded interest rate. However, if we need to do it in an example, we could do this function, f equal to p times I times n, and now that would be the 10,000, open parenthesis, 10,000 again, times I would be the 10% times the years 3, and that will give you okay, there's a addition. Okay, so that will give you the same answer, 13,000. And because we're going to pay this amount back, so that should be a negative. So we put a negative sign before it, which means we have to pay this amount back. On the compound interest rate, there's two ways for doing it. One is to use the function f equal to p times 1 plus I to the power of n. And by applying this, that would be the 10,000 times 1 plus the 10%. You could put the 10% as in decimal, or you could leave it as a percentage to the power of 3, and that would be what would be the future value. Another way for doing it is there's a function called FV, finding the future value, and now we follow the parameter for this function. The rate would be 10%. And then 3, and there's no payment, then we skip that, we add another comma here, and the present value would be the 10,000, or the principal would be 10,000, and you close the parentheses, and that would be 13,310, and it's negative because we have to pay it back. And the same thing, what we need to do, we have to add a negative here for this answer. So this is a short video, quick video that I want to share with you here to differentiate between the simple interest rate and the compound interest rate. I hope this is helpful. I'll see you in another video. See ya.